everyone. So, looks like today it's going to be like Stories Day or Conference Stories Day, but today I'll talk about change detection, Zone.js, and a signal story. I'm Enea Jahollari, and I'm a GTE for Angular and a software engineer at Pushbase. I'll start short. Here we have a component that shows a count, and then we have a button that updates that count. So this is just a pretty normal component that is supposed to work. But how does Angular know when something changes? How does it know when that count updates? Maybe it runs some change detection on every event that happens. Let's check it out. Maybe in our case, it will run some change detection code after that on-click event happens. So this is some imaginary code where we have the event listener that is supposed to be generated, and then we have that Angular that runs change detection. As I said, this is just imaginary code. So in our case, we click, but what happens is all the time, we cannot have just synchronous code. We can also have asynchronous code. And in this case, what happens if we have that set timeout after 1 second, so that count won't be updated directly? To better understand this, I'm adding some console logs to test here now. And if we see the logs after we run that code, we will see that first we will have the before that will log 0 for the count. Then we will have after that will log. Then we will have the changed log that will happen after 1 second. So this means that code doesn't run synchronously, but updates based on the event queue. And then, if we apply the same logic as before, we have to run change detection after that event call. But in our case, that change detection will happen before the count was updated, so before the changed log. And of course, at that point, the count will still be 0, and that will be a broken state because the change detection ran faster than it was supposed to do. So that, of course, will upset our users. So, and the best place to run that change detection would be after that set timeout. So after everything has been updated, we need to run that. If you're familiar with Angular.js, it will be something like scope.digest. But we're on Angular, so nothing like that exists. Or does it? So the question is how to run code after some asynchronous event. And Angular solved this issue in 2014 with Zone.js. Here's a video by Brian Ford, a previous Angular team member, who explained how Zone.js works and how it's basically an execution context. You can check that out later, of course. What Zone.js does is it monkey patches almost all the browser APIs in order to get notified whenever an event happens. So it's like a wrapper around all the browser APIs. It doesn't let anything get out or get in without it knowing. And what it will do is it will grab all those APIs and it will update all of them the moment that an application starts. So it will update add event listener, on props, things like on click, on mouse down, and things like that. But also set timeout, set interval, XML HTTP request, promises, request animation frame. And I'll share the slides later, but you can see the full list. And that's a huge list. Basically, Zone.js is listening all the time for any event that happens. Let's learn Zone.js a little bit by practice. Let's say we have that set timeout that we had before that runs some console log after 1 second. In order to learn Zone.js, we need to first import it. So we import Zone.js. And what this import will do is it will run some side effect that will immediately just update all the browser APIs. It's the first thing that runs on every Angular application. Then what we can do is, because the first import, let's say, patched the browser, what we can do now is fork some kind of zone that it has now. So fork the execution context so we can create our own and extend it. And what I've done here is that I console log before the task, then I delegate So I run invoke task from the delegated, let's say from the previous zone that I had. Then I console log again after the task has been run. And if an event is registered inside the zone that we create, every time that that event happens or emits, it will trigger this function. And we can run something inside zone using zone.run. And then what we can do is run that set timeout and console log something. And if we see the logs, what it will run, what it will log will be before task, so something before. Then it will log hello world, something in the middle, and then after task. This means that Zone.js is capable of, let's say, intercepting even asynchronous code, asynchronous changes. And that's Angular with Zone.js. But before I go a little bit on it, let's say this is an application, and the component structure looks something like this. So we have app component, sidebar, nav item, movie list. This is how it looks like, but we can also showcase it as a tree. So here we have a component tree, which has the application ref. And the application ref, it's nothing else than the class that gets returned when we bootstrap an application in Angular. It has some kind of methods like attach, bootstrap, destroy, and the tick method that we'll see a little bit later. Angular with Zone.js, it's nothing else than the component tree wrapped with Zone.js. So Zone.js will intercept everything that happens inside of that. But as we saw here, we have also the ng-zone. But what is ng-zone is basically a fork of the zone that we saw before. So Angular itself forks Zone.js the moment that it gets, let's say, initialized, and just applies Angular custom logic that it needs. One other thing is it has this onMicroTaskEmpty, which is nothing else than an observable that will emit when all the asynchronous operations are finished. Things like set timeout, set interval, or add event listener, doesn't care. It will know that the event queue is empty. And it will, of course, emit that as observable. Event emitter is just a subject under the hood, of course. OnMicroTaskEmpty will be subscribed inside this ng-zone change detection scheduler that Angular uses under the hood. And what it will do is it will run that application tick here that we saw before. So because we have this wrapped with Zone.js, it means that the moment that that onMicroTaskEmpty observable emits, it will go to application ref and it will call tick. But what is this tick method? Well, remember that imaginary Angular run change detection code? It is something like that. And if we check that tick, what it will do is basically go and call detect changes in attached views. And our attached view initially is that app component that we bootstrap in the beginning. One other thing we have to know now is some change detection states. Basically, there are two states, the most important one in Angular, that are the skipped state, where nothing was done, no check, no refresh, no DOM update, and the refreshed bindings. I say refreshed bindings because in Angular, there's no concept of rendering or re-rendering. Angular never recreates everything from scratch. It just checks what DOM was updated, what state was updated, and only apply those state changes to the DOM. But if the state wasn't updated, DOM will never update. So on tick, what we have is it will go to app component and run change detection somehow. And then it will go to the first branch, refresh everything, go to the second one, refresh, third refresh, fourth refresh. So Angular refreshes bindings from top to down, to bottom, sorry. And as I said, refresh binding means if the previous value is different from the new value, if it's yes, update DOM, no, skip DOM update, no work. But how to skip checking everything every time? We saw that all the tree was green. So it means it was checked, and if something changed, it updates the DOM. And that's where dirty marking and OnPush come to the rescue. A component is marked as dirty by event listener things like click, mouse over, and output emissions. Let's say we have a button where we register a click handler and let's say a select component that has some open change output emission. Angular under the hood will create something like wrap listener that we have here. And inside that wrap listener, we have wrap listener and mark dirty method. And that mark dirty will call this mark view dirty code. And that will just mark the component as dirty. The other thing is set input. If you have ever used something like component ref and you needed to set some input on that component reference, you'd use set input to update those inputs. And that set input basically just also call mark view dirty. But what is this fourth one? Any guesses? Async pipe? Okay. Any other guesses? Correct. That is mark for check. And if you check the mark for check source code, that is basically just calling mark view dirty under the hood. So if we look at mark view dirty, it just has this LView flags that we don't have to carry its internals. But it just sets that flag. It just sets one object field to a value, and that's it. Nothing else. Just a check. And of course, it will go to each parent, each ancestor, and update those flags too, to mark all of them as dirty. So we have a third state, which is marked as dirty. But it just means it's marked, but no check is done yet. So let's see how a button click works. Let's say we have the button click here. The moment that we click, we know that the event listener had that mark view dirty, right? So it will call that function. And then it will just go to each parent and mark that, sorry, each ancestor and mark those as dirty too. So it's just marking. Then we have Zone.js. We shouldn't forget about that. And because Zone.js, let's say, is notified by the click because it uses add event listener under the hood, the moment that that finishes, the microtask empty will be empty. So the microtask empty observable will emit, and it will call tick. And the moment that it calls tick, it will go to app component, and we render the whole, refresh the whole tree. So we have top-down refreshing again. But let's see how OnPush, let's say, optimizes this even further. In order to enable OnPush, we can just go on change detection on the component decorator and set it as change detection strategy.onPush. And we have two change detection states. We have OnPush component, which will be refreshed if the inputs were changed or updated from the parent. And it uses, of course, triple equals for checks. So it checks the reference. And OnPush dirty, so something that is on push, but it was marked as dirty by itself, by some event that it emits, or by its children. And it will be refreshed on the next change detection that happens. So I've marked these two components, and then I do the same thing. I click, it will mark ancestors as dirty, microtask empty will emit, it will tick, and then it will go to these two components. It will see maybe that the inputs didn't change, so it will skip them and refresh the whole other part. But as we can see, we have half of the tree now that doesn't do any checks, anything. It just skipped completely. But if the inputs change, of course, we have an OnPush with inputs change, and what it will do is just refresh it. And of course, refresh other parts, but the middle one didn't change anything, so it's safe to keep it as is. But let's mark also this other one as OnPush. And then we click again. And then we have that dirty OnPush component. And that at that point, we know that even if it's dirty, we always need to refresh it because something changed there or in its children. So we still have the same state, like we update the, let's say we'll refresh the DOM for those parts. And of course, skip the other part. So we see that with default change detection, we have too much checking, while with OnPush change detection, we skip branches of that component tree and do less checking. Let's look at the async pipe now, and I have to ask, does it really do any wonders? because it just uses mark for check under the hood. It still marks the whole ancestors as dirty. And this is the source code if you care about it, like check. It will basically, on update latest value, just run mark for check, and that's it. I've also written about it in justangular.com on how to recreate this whole async pipe in order to get a better idea of how that works. So let's use the async pipe. We have the to-do async. And then it will, of course, the moment that that to-do emits something, it will mark ancestors as dirty again. Then we have the part where what triggers the tick, because we saw that Zone.js was not notified, right? Because we don't have that click. But as we saw before, Zone.js doesn't care about only clicks. It patches all the browser APIs. So if we have an HTTP request, it will, let's say, it will know where a HTTP request happens and finished. Or if we have that on click, as we saw, and we update that observable, it will know from the click handler that something was updated. Or if you run something synchronously, like to do next inside ng init, because that's synchronous code, Angular supports synchronous code automatically on the first change detection, so everything should work fine. If you have some set timeout that you update some state, well, Zone.js patches that too, so it also knows that something changed. Then the part is what happens if you run something outside Angular and you update some state inside the set timeout. So that set timeout that we have there is not patched. Is it broken? So is it going to work? Before v17, we won't see any state updates because it runs outside Angular. Nothing notifies Angular that something changed. But in v18, it will work, even if you run it outside Angular, because it will call the mark for check inside that async pipe. And that mark for check will tell Angular, hey, Angular, something changed. You need to update this no matter what. So we have that to do async that has some patched event that happens at that point. And of course, it will notify Zone and update the state. But why do we need to mark all the ancestors as dirty? Like, why do we need to check everything? Well, let's dirty mark only the updated component that we have here, but not all its, let's say, ancestors. What happens is that we refresh app component because it's a normal component. Then we come here, and it's an OnPush component where probably the inputs didn't change. And of course, it will be just skipped because there's not marked as dirty. And what happens is the whole branch will be skipped. And that component that was updated won't be updated on the DOM. And we are on a broken state here. We don't want that. We want our DOM to update every time our component state changes or application state changes. But can we do better? Of course we can, and that's what signals are for. Here's just a short intro on signals. We can create signals using the signal function call. We can create some computed, which, let's say, will rerun some computation only when that signal inside of it changes. We have an effect, which will run every time the signals that are called or read inside of it will change. And of course, we have that set timeout that just changes the name. I have forgotten to put name.set there, but you get the idea. And of course, we will see two outputs, the first John and Jane and Jane, because of the effect. But we can use those signals inside Angular templates. And you can see that we have called that name as a function. And we were used to saying that it's not OK to call function in the template because it's bad for performance. But we see that signals do that now. And before, in order to fix that, we had to use something or create something like a pipe to memorize the computation. And I've written a blog post about it that says it's OK to use function calls in the Angular templates. And we go through how Angular works with pipes under the hood and how that is just a function call itself. What we can say is that Angular templates are now effects, or how it's called internally, just consumers of those signals. And every time a signal that is read inside the template is updated, that component is marked as a refresh view. A refresh view tells Angular to refresh this view on every change detection, No matter where it is, no matter what happens, it needs to be updated because something changed. One other state is, or marker, is has child used to refresh. And this is applied to the ancestors of a component with refresh view. It just sets a flag, nothing else. Let's say now we have a signal read in the template here, a to-do. The moment that it changes, it will, of course, mark the ancestors as has child used to refresh. But in v17, signals still rely on Zone.js to trigger tick, because Angular refreshes only when there's a tick, no error. So the to-do probably will be changed the same way as the async pipe, maybe by some HTTP request, maybe some click, some set timeout, or some other event. And of course, we have microtask empty, then we have application ref tick. It will go to the app component. And of course, it will check this has a has child view to refresh flag. And that's where the new change detection mechanism comes in. And it's called targeted mode. But did we have any kind of mode before? Well, yes, it was global, like check everything that is a check always, or what we call default change detection, and if a component has OnPush and dirty. And the new targeted mode will be activated if we have an OnPush component and the has child used to refresh flag, like both flags at the same time. And on targeted mode, Angular will refresh everything that has a refresh view flag set. And at that point, the moment that it reaches that, it will traverse children in global mode again. So this way, Angular can keep backwards compatibility with older applications or older types of components that use default change detection. So what this means is that Angular will still support every kind of component that you have, even if it's on push, default, or whatever kind you create. If it has a signal read in the template that changes, it will be updated. These are some rules. You don't have to check now, but you can screenshot maybe later, because I'll share the slides and just check it for your own interest. So we can say that if we have an onPush and child used to refresh, it will be skipped, but it will be converted to targeted mode. And then on targeted mode, we see that only the refresh view gets skipped, but at that point, after we check the first one, we convert back to global mode. So at that point, the moment that we have the change, Angular will go and, of course, go to the app component. And on app component, we're still on global mode because the tick, by default, runs on global mode. It will be refreshed, of course, because it's just a normal component default strategy. And then we have the first one that is on push. That still works the same. No inputs change, skip. Second one, same idea, skip. Then we come to the onPush and has child used to refresh that we saw before. And at that point, we convert to targeted mode. But we don't refresh this component because it's not changed or not marked as dirty or refresh view. Of course, skip it. We don't refresh anything. But we traverse children in targeted mode now. Because we are on targeted mode and this is just a normal component, we don't refresh it because, as we say, we only refresh the refresh view components. So we skip it. Here we are in a refresh view component. We refresh it. But at that point, we convert to global mode because we can have some other, let's say, legacy component that we use inside of that component. So at that point, we are again on global mode, and we refresh. Of course, refresh also the other branches normally. And of course, this is way better because this means that we can skip refreshing parent components if they didn't change or if they were not marked as dirty. And we can have a lot of parent components in our component tree that if are marked as onPush or even not as onPush, they won't be refreshed for some cases. And of course, we can, of course, skip a lot of trees, a lot of branches like this. But keep in mind that targeted mode only gets enabled if it reaches an onPush and that has child used to refresh flag. So if it's not dirty somehow. So we can say that Angular knows when something changes by Zone.js. So all those events mark for check, which tells it that something changed, or that signal updates. So these three pillars. But let's go zoneless. And that means just kill the updates that come from Zone.js. but we still have mark for check and signals. So with Angular and Zone, we have this kind of pattern we saw. And then with change detection scheduler, that's a new class that Angular implemented, is just the same thing. So we see that it just replaces it. But it doesn't replace it everywhere. It replaces it only for some kind of things. And we will see that in a bit. So we have that change detection scheduler, which will run a request animation frame and set timeout, and it will raise them together. And the first one that, let's say, emits, at that point, Angular will call that tick method. So how does they compare? With Zone.js, we have browser asynchronous events that tell Angular that something changed, like add event listener. But with change detection scheduler, Angular will update only when there's a change from inside the Angular itself. Because we have things like signal updates now that tell Angular that something changed, or mark for check with async pipe, for example, or listeners that we click, or set input when we attach a view or detach it, or when we have async animations that are loaded, or render hooks, or defer block state updates. And I didn't show this before, but basically mark view dirty now will tell the change detection scheduler that, hey, something changed. You need to run tick. This means that Angular will work in a zoneless lab by default. And to enable it, we have experimental zoneless change detection API, which we can use. And also, what we can do is we can remove the Zone.js from polyfills now. And of course, it will remove 15 kilobytes of code and all that time that it needs in the beginning to execute. And with Zone.js also, debugging some code will look like this. So we remember those onInvoke tasks that we saw? Or invoke task and all those things? Well, without Zone, that is basically anonymous part that is function that will just the click event, the wrap listener that we saw, then we have the execute listener function that Angular calls, and it will just call the our click. And of course, run the onClick method. So Zone.js disappears from our stack trace. And as I said, in Angular v18, it works zoneless by default. So if you remove it and only rely on signals and mark for check, everything should just work fine. But you don't have to care all about this. So it's all those refresh, global, targeted, everything. That's not the point of this talk. The whole point of this talk is that it's Angular's job to do that. If we just use signals or mark for check with OnPush or not, everything will be fine. And there's libraries that help with signals. There's NGRX that we saw before. There's RX Angular, which has added support for signals. Then there is NG extension, which, let's say, enables you to migrate to signals code, like view children, content children, signal inputs, and things like that. You can check them out later. But if you want also better performance, you can check Michael Slatke, Angular Performance and Core Web Vitals in 2024. And then there's also concurrent mode in Angular, which improves performance a lot more. If you want to check the slides, there's this one. 5 seconds if you care. 1, 2, 3, 4, 5. OK. One, 2, 3, 4, 5. OK. Share with each other. So this was a change detection, Zone.js, and signal story. Follow me on Twitter for any kind of Angular news, signals, updates, PRs, and more. Thank you.
Thank you. Thank you very much.